Okay, last two from problem set F are the two from 2010. So 2010, number one. I'm sorry, when I screenshot it, it got real smushed in here. We've two rates. Please make sure you read the question. Snow accumulates according to F, and then once Janet wakes up, the rate at which she removes snow is given by G. So F of T, accumulating snow. G of T is the removal of snow. So A, how many cubic feet of snow have accumulated on the driveway? So simple integral from 0 to 6 of the function f of t, and verify in your calculators that that would be the answer you get. You don't need to identify any type of units. Okay, for B, find the rate of change of the volume of the snow on the driveway at 8 a.m. So rate of change, we're talking about derivative. So what's the rate of change of the volume at time t is equal to 8? Okay, so the volume of the snow, that's the antiderivative of the rate at which it falls minus the antiderivative of the rate at which Janet takes it off the driveway. So if we want the rate of change of volume at time t is equal to 8, so if I plug in our boundaries here, and this would just be x. When I derive the antiderivative, we know that that just undoes. They're inverses of each other. So f of 8 minus g of 8, verify in your calculator that the answer is negative 59.583. No units needed. Okay, C. Let h of t represent the total amount of snow in cubic feet that Janet has removed from the driveway at t hours after midnight. Express it as a piecewise function on the domain from 0 to 9. So h represents the total amount of snow. So to determine h of t, we're going to need to integrate some function because f and g are both rates. So just using our units, and we know the answer is going to be in cubic feet. Again, cubic feet per hour, they're the rates at which we're given. Okay, so this is going to be the total amount removed. So we have three pieces of our function here. Between 0 and 6, it'll just be the integral from 0 to 6 of the rate at which Janet is removing snow. And that's nothing. Still sleeping. Between 6 and 7, the rate at which she removes this, or the total amount of snow removed, we would take the total amount from here, which is just 0, so nothing has been removed yet, and we're going to add to that the rate at which she removes the snow between 6 and 7. So our boundaries here are going to be from 6 to t, because t has to be a value bigger than 6, and it'll be some number less than 7, but we don't know exactly what it would equal. So this would be the integral from 6 to t from the piecewise function of 125 dt. The integral of 125 is 125t. We evaluate that from 6 to t. So that's 125t minus 125 times 6. Now if you're checking the solutions online, they write it as 125 times the quantity t minus 6, which will be very useful to us to answer part D. Okay, now, so this is still to finish C. Between 7 and 9, the total amount of snow that Janet has removed, it would be the amount of snow she's removed by the end of 7 hours plus the integral from 7 to t of the rate at which she removes the snow. Alright, so let's focus on this. From the piecewise function, this would be the integral from 7 to t of 108. So that's 108t from 7 to t. And using the same format, okay, this would really be 108 times t minus 108 times 7. So just factoring out that 108 there. But now h of 7, we just determined on the previous slide how to find the amount of snow she removed for any time between 6 and 7. So at the end of that interval, Janet has removed 125 cubic feet of snow. So this would be 125 plus 108 times t minus 7. And that'll give us the amount of snow removed on the time interval from 7 to 9. So now let's put it together as a piecewise function. Okay, so now let's put it together. Express h as a piecewise function. So h of t between the hours of 0 and between midnight and 6 a.m. Janet hasn't removed any snow. Between 6 and 7 a.m. the total amount of snow she removed would come from this function, where t is a value between 6 and 7, between 7 and 9. Then the total amount of snow that Janet removed would be according to this function. So putting those three pieces together, and they have to be three separate pieces because the domain is switched. And lastly, part D, how many cubic feet of snow are on the driveway at 9 a.m.? Okay, so now this is, we'll use C, but it's a different question that it's asking. So the amount of snow will come from the total amount that's fallen minus the amount that Janet has removed. So the rate at which the snow falls was given by F, so we have to integrate from 0 to 9 to get the total amount of snow that has fallen, and then we're going to subtract from that the amount that she has removed. So at time 9, we use this piece. H of 9 is going to represent the amount of snow that has been removed. So we'll subtract from that H of 9 and then verify in your calculator. That's how much snow has been removed at 9 a.m., 9 hours after midnight. Okay, last one. Number 3 from 2010 as well. 700 people in line for an amusement park ride, so that's our initial condition. Once the ride opens, passengers are allowed onto the ride until 8 o'clock at night, 8 hours later. People move onto the ride at the given rate, and then this graph, R of t, shows the rate at which people arrive at the ride throughout the day. So they get onto the ride at this rate, they arrive at the ride that rate, and 700 people are waiting before the day even starts. How many people arrive at the ride between 0 and 3 hours? So we're going to integrate from 0 to 3. R of t is our function defined by the graph. So I broke this into the area of 2 trapezoids. And you can verify that the answer is 3,200 people arrive on the ride between 0 and 3 hours after the park opens. Is the number of people waiting in line to get on the ride increasing or decreasing? So the number, I wrote a little equation first. Number of people waiting, and I'm going to refer to this as W of t. Alright, think about all the pieces here. 700 people are there before the park even opens. I have to add to that the total number of people that arrive at the ride. So that would be the integral from, we'll say 0 to t of r of t, because that's the rate that's given people arrive at the ride throughout the day. I have to subtract from that the total number of people that actually get onto the ride. And we're told that the rate at which people get onto the ride, it's a linear rate. So I'm looking specifically between 2 and 3, and I want to know, is this number increasing or decreasing? So we know function increases if derivative is positive. Function decreases if our derivative is negative. So let's find w prime of t. And again, this is what I'm calling w, and we'll come back to that. So w prime of t, using the second fundamental theorem, that would be r of t minus 800. Okay, so where does the derivative equal 0? The derivative would equal 0 when r of t equals 800. From the graph, that occurs at time t is equal to 3. So at 3 is the turning point. So any time between 0 and 3, my derivative is positive. So if my derivative is positive, the function is increasing. Therefore, number of people waiting is increasing. If we look at setting w prime of t equal to 0, or your function's going to increase if this number is greater than 0. So where is r of t bigger than 0? It's greater than 0 on the interval from 0 to 3. So since this rate is bigger than 800, same conclusion. Our rate would be positive, therefore our function is increasing. Alright, C, at what time t is the line for the ride the longest? So we're looking for an absolute maximum. Absolute maxes we know are going to occur endpoints or turning points. Okay, we already know that 3 is our turning point because that function that I called w, waiting in line, and that occurs when t is equal to 3. And if we look at the derivative function, the derivative is positive before 3 and negative after 3. Okay, so we test these 3 values. And remember what I defined w of t, the total number of people waiting in line, 700 plus, it's not 3,200, the integral from 0 to t of the rate at which they arrive at the ride, and then I'm going to take away from that the total amount of people that get onto the ride between 0 and t. Okay, so I'm going to run out of time here. We'll finish this in class. So what I want you to do, attempt the remaining 4, at least read them and attempt a solution. Numbers 2 and 3. These aren't due until after your multiple choice calculator test in class.